All right, section 2.5, video 2. Let's go ahead and get right into the examples. Example 3. Cruising Tunes determines that in order to sell X units of a new car stereo, the price per unit in dollars must be P of X equals 1,000 minus X. It also determines that the total cost of producing X units is given by C of X equals 3,000 plus 20X. So notice that that little p, this thing right here, that is the price, not the profit. That's different. We're going to use a capital P for the profit. So we want to find the total revenue. Well, if you think about it, the total revenue is how much money you make. So in order to figure out how much money you make, you've got to take how many items you sell and multiply that by the price. For example, if I wanted to say that I'm going to sell a CD for, $10 and I want to sell 5 of them, then I'm going to make 50 bucks. That should hopefully make sense. I just took the price, $10, and multiplied it by the fact that I sold 5. So it's the same idea here. Our revenue is going to be the price. Well, the price was given to us as 1,000 minus X times the number of units that I sell. Well, X represents the number of units that we sell, so there's our revenue. 1,000 minus X, that's the price, times X, the number of units. Then if I want to find the total profit, we know that the profit is revenue minus cost. So profit, in this case, our total profit, again, capital P for profit, is going to be the revenue. Now I'm going to distribute the X for the revenue, so it's going to be 1,000 X minus X squared minus the cost, which is 3,000 plus 20X. And we can actually simplify that just a little bit. We can subtract off everything. So it looks like we're going to get a total profit of, let's see, negative X squared. I have a 1,000X minus a 20X, so that's going to be 990X. And then we still have to do minus 3,000. And that's our profit. So now we want to do some actual calculus. It says how many units must be made and sold in order to maximize the profit. So I want to maximize the profit. I'm going to take the derivative of profit. So P prime of X, and again, we're going to go from this one right here, is going to be minus 2X plus 990. And if I want to figure out the maximum, we're going to set that equal to 0 to get the critical value first. So I'll add 2X to both sides. And then we're going to divide both sides by 2. And we're going to get, what is that? 495. Am I doing that correctly in my head? No, 490. Oh, no. Okay. I made a mistake. Hopefully you guys caught this. Let's go ahead and fix that. I did 1,000 minus 20 and got 990. It should actually be 980. So let's go ahead and change that to 980X, which is going to make this different down here. Come on, erase. There we go. So that's going to be 980. Okay. Now we'll divide by 2, and that's going to be 490 and not 495, like I said. So 490. Okay. Let's double check to see whether that's actually going to be a maximum or minimum or what it is. So I can take a second derivative. And the second derivative is just negative 2. Again, that's negative 2. Second derivative being negative means that it's concave down, which means that it has to be a maximum at my critical value. So 490 does maximize the profit. So it says how many units must be made? Well, that's 490 units. So 490 units will maximize profit. And then I believe it says what is the maximum profit, right? In order, no, how many units must be made and sold in order to maximize profit. Okay, so yeah, that looks like 490. Yeah, that's right. Okay, It's part D that actually asks us how much is the maximum profit. So we're going to take 490 and we're going to put it back into the profit equation. So the profit of selling 490 units is going to be negative 490 squared plus 980 times 490 minus 3,000. All right, and again, I'm not going to do all that in my head, but we plug that into our calculator, and we're going to get, looks like $237, $237.10. Is that right? No, I've got my decimal in the wrong spot. It's $237,100. That's right. Okay, there we go. Yep, there we go. $237,100 is the maximum profit. And then what price per unit must be charged in order to make the profit? So now we actually have to go back to the price. The price equation was given to us up there as 1,000 minus X. So the price, we'll do try and do a little lowercase p here. The price of selling 490 units is going to be 1,000 minus 490, which means $510 would actually be the price that would maximize the profit. All right, example number 4. This one's one that took me a few times even to read it and make sure that I understood what was actually happening here, so we'll go through it relatively slow. By keeping records, a theater determines that a ticket price of $26, it averages 1,000 people in attendance. So if you charge 26 bucks, you're going to get about 1,000 people in attendance. For every dollar that this ticket price drops, it's going to gain 50 customers. So in other words, if I drop it to $25 per ticket, I'm going to go up to 1,050 people, and so on. For every dollar it drops, it's going to keep going up. Each customer spends an average of $4 on concessions. Okay, so that's just a flat thing. It's going to tell us that $4 in concessions is how much they spend. What ticket price should the theater charge in order to maximize total revenue? All right, so let's go ahead and figure something out here first. First of all, the revenue is going to be made from not only the tickets, but also from the concessions. So it's going to be the revenue from the tickets plus the revenue from concessions. That's just awful. Concessions. Sorry, my writing is not very good here. All right, so that's our revenue. The revenue that you get from the tickets plus the revenue from the concessions. So let's figure out how to figure out the revenue from the concessions. Well, from the tickets. It's the number of people that buy tickets times the ticket price. So let's write this as, the number of people that buy tickets times the ticket price. Okay, that's the revenue from the tickets. And then the revenue from the concessions is once again the number of people that buy tickets. Number of people that buy tickets times 4. And that's just because they spend on average $4 on concessions. So the biggest things we need to figure out is how many people are buying tickets and what is the ticket price. If we find that out, we can do the rest of this. All right. Well, the number of people that buy tickets, let's see, it averages 1,000. But then we have to add 50 more people for every time that the price changes by $1. And the ticket price changing by $1 would just be 26 minus X, minus a person buying a ticket. So every time we reduce the ticket price, which is X, by $1, the number of people going up it's going to increase by 50. So that looks right. And then once again, the number of people buying tickets is going to be 1,000 plus 50x, and then times 4. So that is our revenue. Now we can simplify all that. We're going to go ahead and do some distribution and combine some like terms. So let's go ahead and do that. First one, we have to FOIL. Oh boy, going to be some big numbers. Let's see, 26,000. Let's see, outside is going to be minus 1,000x. Inside, what is that going to be? So I believe 50 times 26 is 1,300. So we get negative 1,000 plus 1,300 is plus 300x. And then we're going to get minus 50x squared. Okay, and then we'll just go ahead and distribute the 4 into the other parentheses. So that's going to be 4,000 and plus 200x. 200x. Now let's combine everything and reorder it. So our revenue looks like it's going to be negative 50x squared. Let's see, combining 300 and 200x gives me 500x. And then 26,000 and 4,000 is 30,000. So that's our revenue. Now I want to figure out how to maximize the revenue. So now we're going to use calculus. We're going to take our derivative. So let's go ahead and take the derivative of r. So we get r prime of x. So it's going to be negative 100x plus 500. We have to set that equal to 0. Setting that equal to 0, if I add 100x to both sides and then divide by 100, we get that x must be 5. Let's go ahead and double check that this is going to give us a maximum. If I take the second derivative, well, the second derivative is negative 100. Once again, that's a negative number, so that is concave down, meaning that this has to be a maximum. So we found the number here, that the x value that's going to give us a maximum. So what is the question actually asking us here? What ticket price should the theater charge in order to maximize total revenue? We're not even asked to find the maximum total revenue, so we don't have to do that step. We just need to know the ticket price. Well, the ticket price comes from this piece right here, which is this one. So all I need to do is I need to plug my x value back into that. So it looks like the maximum or the ticket price that's going to maximize our revenue is going to be 26 minus 5, or $21. So it looks like if we charge $21, we're going to maximize our revenue. All right, one more to go. And this one will be a little bit different. We'll kind of walk through that one slowly. All right, in our last example, we're talking about inventory problems. The biggest part about this one is going to be the setup. So in a general inventory problem, and this is just kind of a hypothetical situation we'll go through real quick. Let's say I own a small electronics shop and I sell 500 big screen TVs per year. I probably don't want to order 500 TVs to all arrive on the same day on January 1st and then sell the TVs throughout the year, because if that was the case, I'd either have to rent a really large storage facility and then have some of it that would sit more than empty for half of the year. Or on the other hand, I probably don't want to order too many TVs too often, because then you're going to have a bunch of delivery fees and stuff like that you don't necessarily want to do. So you kind of have to balance this out. How much stuff do I want to be sitting there for how long? And then how many times do I want to reorder things? That's kind of the general idea behind inventory. So we're going to make some assumptions. First of all, our items sell at approximately a constant rate. Of course, we know that that's not true, because there are certain times of the year that are going to have much more sales than others, but we're going to assume that it's a relatively constant rate for this particular problem. We're going to purchase the same amount of items each time. So every time we order a number of items, you know, we might order 10, and the next time 10, and the next time 10. It's not going to vary. And the total cost is the yearly carrying costs plus the yearly reordering costs, where the carrying cost is defined by the yearly cost per item times the average number of items, and then the reorder cost is the cost of each order times the number of reorders. Now, it's the average number of items and the number of reorders that's really going to be the part that we have to think about. So let's go ahead and do our example, and do your best on this one. If you got to keep going back and forth between all this, that's fine. Um, okay, so Fred's Electronics sells 2,500 television sets per year. It costs $20 to store one set for a year. To reorder, there is a fixed cost of $20 plus a fee of $9 per set. How many times per year should the store reorder, and in what lot size, to minimize the inventory costs? Because obviously you want to keep your inventory costs down. So let's go ahead and we'll kind of go back up here just to look at this. We need to figure out, first of all, what the yearly carrying costs are. So we're going to start with this one. We're going to do the yearly carrying costs. So let's do the yearly carrying cost. Well, that means we need to figure out the yearly cost per item. Well, according to what it says here, it costs you $20 to store the item. So that's a carrying cost. And then we have to figure out the average number of items. Now, normally, if you take an average, you add things up and then divide by how many there are. Well, we're going to assume in this case that we're going to take the number of items, X, and just divide it by 2 to do an average. Okay, that's going to be our yearly carrying cost. Then we need to look at the yearly reorder cost. So yearly reorder cost. Okay, so that's going to be the cost of each order. Well, let's see what it says here. There's a fixed cost of $20 to reorder, plus there's a $9 fee per set. So it's 20 plus 9x, because it's the number, x is the number of sets. Okay, so then we have to multiply that by the number of reorders. Well, we obviously don't know how many reorders we're going to have, but we do know that if we have 2,500 sets per year, we need to divide that by however many sets we're going to have. So it's going to be 2,500 divided by x. So that's going to give us our yearly carrying cost and our yearly reorder cost. So to figure out the whole cost, just add them together. Let's go ahead and simplify as we go. So the first one, the carrying cost, is 20 times x over 2. Well, that's just 10x. So this will be our cost function, 10x. And that comes from simplifying this one. And then in the next one, let's see, we're going to have to multiply 2,500 times 20. Well, 2,500 times 10 is going to be 25,000. So times 20 would be 50,000. So that's going to be 50,000 over x. And then when I multiply the 2,500 over x times 9x, the x's are going to cancel out. So we're really just going to get 2,500 times 9. Let's see, 2,500 again times 10 would be 25,000. So if we subtract 2,500 from 25,000, we get 22,500. Now, you don't have to do all this stuff in your head like I'm doing. Just, figure it out doing your calculator. It's okay. That's our cost. Now we're trying to minimize this. So let's go ahead and take a derivative, which is just going to be 10. Now, don't forget, 50,000 over x is like 50,000 x to the negative 1. So really, I should erase that because we're going to get negative 50,000 x to the negative 2 power, and then the derivative of 22,500 is 0. So we're going to set that equal to 0. We're going to go ahead and solve this. So I'm going to add the 50,000 x to the negative 2. And remember, 50,000 x to the negative 2 is the same thing as 50,000 over x squared. So I'm going to multiply both sides by x squared because I got to solve for x. Divide both sides by 10, and that's going to give us 5,000. I was really hoping that this was going to end up being a perfect square. It's not. So x is going to be the square root of 5,000. Now notice we don't need the minus there because that doesn't make sense. That would be a negative number of items, and that doesn't make sense. So we don't have to do the plus or minus here. All right, that comes out to be approximately 70.7 items. We'll use that later just to make sure. That gives us somewhat of a a real number idea. Let's see. We're trying to minimize this, right? Yeah, minimize. So let's go ahead and double check that this is a minimum. So we'll take a second derivative, and the second derivative is going to be, let's see, positive 100,000 x to the negative 3, which is the same thing as 100,000 over x cubed. Well, any positive value that I plug into there is going to be positive, and obviously we're talking about a positive number of items, so this is going to be positive, which means that it's going to be concave up, which means that this is a minimum. So we have now found the appropriate number of items for the minimum. Did it ask us for the actual value? How many times per week, I'm sorry, how many times per year should the store reorder, and in what lot size? Okay. So now we know that we're going to reorder 70.7 sets. Obviously, it's probably going to be rounded to like 71 or maybe rounded down to 70. And then let's see how much that would actually be. So we're going to say, let's just say it's 71, because I think you would round that up and order one extra as opposed to one less. So we're going to do the cost at 71. And if we plug that one back in, I pre-did this one in this case just to save a little bit of time. That's going to be 23,914 and 23 cents. So 71 sets are ordered, $23,914.23 would be the cost. And there you go. That should be plenty enough for this section. Good luck.